everyone, today in Integrated Math 2 we're going to go over Chapter 5, Lesson 2. So here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple of the key concepts on the properties of real numbers. So it says the following properties are true for all real numbers a, b, and c. So keep that in mind, a, b, and c are all real numbers. So the addition property of equality is if a is equal to b, then a plus c is equal to b plus c. Notice all that's happened here is that we added the plus c. It's still equal, hence the name addition property of equality. As long as it's done to both sides, it remains equal. Then we have the subtraction property of equality. Once again, if a is equal to b, then a minus c is equal to b minus c. Notice we have b minus c again to both sides. This is why it's called the subtraction property of equality. It has a mess with it being equal to each other. Then we have the multiplication property of equality. If a is equal to b, then a times c is equal to b times c. Same idea as addition and subtraction property of equality. We're multiplying c to both sides this time. We haven't changed anything. We know that both sides are equal to each other. Then once again we have the division property of equality. If a is equal to b, and this is something a little new, and c cannot equal 0 because you can't divide the numbers by 0. Assuming that's true, then we can say that a divided by c is equal to b divided by c. So they're both just being divided by c. So then we have the reflexive property of equality if a is equal to a. The way I remember this is if you're looking in the mirror, you see yourself, you don't see someone else. So the symmetric property of equality, if a is equal to b, then b is equal to a. Notice all that happened was the b and a flipped, but still the same thing. Think about it if we said 5 is equal to x, well we know that is x is equal to 5. We automatically just switch it. It's the same idea. Then we have the transitive property of equality. If a is equal to b and b is equal to c, then a is equal to c. Notice what happens here is that b disappears. I kind of remember it as the middleman just disappears. Substitution property of equality. If a equals b, then a may be replaced by b in any equation or expression because they're equal to each other, so we can replace them with each other. The last one we have here is a distributive property. If a times b plus c, think about it, we're just distributing the a to both. Then we have a times b plus a times c. And there we go. Alright, now we have a couple of different properties. So once again we have the reflexive property we talked about. Let's say we have segments AB is equal to AB. An example of an angle would be the measure of angle 1 is equal to the measure of angle 1. It's the same thing. Symmetric property. If AB is equal to CD, then CD is equal to AB. So same thing as we talked about before, except now we have angles and segments. These two are equal to each other, so we can flip it as well. Flip the order, I should say. Then we have the transitive property. If AB is equal to CD and CD is equal to EF, then AB is equal to EF. That CD disappears. Then we have the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 3. Then we know that the measure of angle 1 is equal to the measure of angle 3. So we are given that 5x minus 3 is divided by 6 is equal to 2x plus 1, and we want to prove that x is equal to negative 9 divided by 7. So if we're looking at this example here, we have 5x minus 3 divided by 6, and that's equal to 2x plus 1. Well, if you're just solving it normally, well, the first step we would do, I should say, is to write what we're given. It's always the first thing. So as you see here, we have 5x minus 3 divided by 6 is equal to 2x plus 1. And our reason is, we are given it to us. Sorry. The reason is because it was given to us. We didn't have to do anything special. Then, you're like, how would I solve this one? Well, if we were just solving it algebraically, you know that we would just multiply both sides by 6. You would do this because you want these to cancel each other out. You want it to reduce to 1. So that's our next statement. We now have 5x minus 3 is equal to 6 times 2x plus 1. What we did here was we multiplied both sides by 6. Well, that's a multiplication property of equality. I did it to both sides. I kept a balance. Then after that, I would see, I'm like, oh, okay, well, I know I'm going to be using the distributive property. And I'm going to simplify that. So I know I would have 5x minus 3, which is equal to 12x plus 6, which is what I have here. And once again, I already knew what it was. It was distributive property. You're continuing these things that you've already done, except now you're giving the reasons and justifying it. Then, as we know, if we were to simplify this, we'd be like 5x because 12x is smaller. So we subtract 5x to both sides. We had negative 3 is equal to 7x plus 6. Well, what you did on both sides, you subtracted. Subtraction property of equality. And then I'm like, okay, I want to get my x's by themselves. So minus 6 on both sides. Notice here I'm just kind of doing the scratch work on the side. When you're doing the proofs, you don't show all that work. You just show what it gives you. So this is negative 9, which is equal to 7x. Well, once again, you subtracted both sides by 6. Subtraction property of equality. Once again. So now we're at the same page. And then I want to get x by itself. So I divide both sides by 7. Well, this is the multiplication property of equality, which will give you x is equal to negative 9/7. And last thing, because we wanted the x on the left-hand side always, x is equal to negative 9 divided by 7, which is the symmetric property of equality. And that's it.